Okay, so here in lesson 2, we are going to go over some operations with complex numbers. Let's start with addition. Addition and subtraction, and actually multiplication, they work pretty much the same way as in vectors, okay? So let's say that we have a complex number, a general complex number z, which equals a plus bi, and w, which is c plus di, okay? The idea is for us to add them, so representing them in the Argand diagram, in a complex plane, here is z, and here is w. So what is the outcome number after adding these two? Let's call it r, which is z plus w, and it's going to be equal, obviously, to a plus bi plus c plus di. So all you have to do is to add them, but you can only add real parts and complex parts. So it's going to be equal to a plus c, the real parts of both z and w, and b plus d, which are the complex parts of z and w. So the outcome is going to be this. You can also represent it in a column form, in which the top line goes for the real part, and the bottom for the imaginary part. It's the same. You may see it both. They mean exactly the same thing. The outcome complex number is going to be this one, r over here. It's just the outcome of adding the real parts of z and w, so a plus c added together, it's this, as you can see here. Same thing goes for the imaginary part. All right, you have seen this before. Subtraction is the same thing. Again, you can only subtract real parts and imaginary parts. So if you have here the two numbers, the real part of the outcome number is going to be a minus c, and for the imaginary part is b minus d. How do you represent this? If you start with the same generic numbers, the outcome imaginary number is going to be this one over here, okay? Again, it's a little bit like vectors, subtracting an imaginary number corresponding to adding that imaginary number multiplied by minus 1, all right? Multiplying by a number, by the way, works exactly the same way. You multiply both the real and the imaginary part by that number, and that's the outcome, and didn't even bother to write it down. So multiplying this by minus 1, for example, it will be equal to minus a minus by. To multiplying by 3, it will be 3a plus 3by, and so forth, okay? Multiplication. It obeys the same rule. You have here both numbers. You just have to cross multiply everything, but that's going to be a trick at the end, okay? You'll have a times c, a times di, b times bi times c, and then you have bi times di, which is basically bd I squared, but I squared is what? Is minus 1. So what is going to be the overall result of that? Is going to be minus bd, which is just real. So this is going to be part of the real part of the overall complex number, the one that is going to come from the multiplication of these two, okay? So it's going to be ac minus bd, this is the real part, and then both these terms, they are imaginary parts, so you have ad plus bci, okay? Not very difficult to understand after, not difficult at all, but you should have this result as a standard result instead of doing this yourself. I think it's simpler for you to move forward in calculations. Division is not that straightforward. So let's say that you have the same numbers divided, z being divided by w. In order for us to figure out what is the resultant complex number, we have to use this method. It's going to be, and we plug it over here, this generic number x plus yi. The purpose is for us to figure out what x is and what y is, okay? So what do? You just multiply both sides by c plus di. That's right, it over here. Obviously, these two will cut out, and you'll have it over there. Now you do the multiplication over here. You just use the standard result, so this is going to be it. And now you compare. The real part is going to be equal to a, and the imaginary part is going to be equal to b. That's what I have over here. And then you solve for x and y. You can go ahead and try it yourself, but eventually you will end up with this, which is the outcome of the division, the thing that we wanted in the first place, is going to be equal to a plus bi, the first number, divided by the second, times the complex conjugate of that one divided by itself. And then you do the cross multiplication, you do the multiplication of the numerators and the multiplication of the denominators, and you end up with this. This over here is the standard result, this one, from multiplying the numerators. And if you try to do this over here, you will eliminate the complex parts and you will only end up with c squared plus d squared. My hint is for you to know this by heart instead of doing all this process every time you have to make a division. Know this by heart and it will be easy for you to understand the value of x and the value of y, which are what, by the way? The value of x is going to be ac plus bd divided by c squared plus d squared. That's your x. And the value of y is going to be bc minus ad divided by c squared plus d squared. I just divided this fraction into two. The one on the left is the real part. The one on the right is the imaginary part. Don't forget that in a real situation, in a real question, a, b, c, and d are going to be numbers, okay? What about the reciprocal, 1 over z? If you apply this, you will learn that is going to be just a minus bi over a squared plus b squared. Just look over here. Now you just have 1, all right? Sorry, this part over here is just going to be 1. So you'll just multiply by whatever the denominator is, the complex conjugate of it, divided by itself, okay? And eventually you end up with something like this, but it summarizes into that. Go ahead, try it yourself, and you'll get that result, which, by the way, you should also use straight ahead. What about the square root? You don't have a general expression to use, so in this case, it's just better to use basically the same method, do the comparison, and solve the simultaneous equations. What do I mean with that? Square root of a complex number a plus by is going to be this generic number, x plus yi. So what do you do in this case? You square both sides, okay? Now, this part, you just take care of that square. This is what you'll get. You will end up with y squared, which is minus 1. So this goes to the real part, okay? And you only have this imaginary part. So now you compare. X squared minus y squared must be equal to a. And 2 plus xy must be equal to b. And now you solve for x and y, and you figure out what the result is.